today we're going to explore the distributive property. And this one's been one you've actually been using since probably about fourth grade when you started learning how to multiply two-digit numbers. Because it's predicated, that concept, the standard algorithm, is predicated on taking the multiplier, which is the bottom one, the second number in the equation. So if I set up one, it's predicated on the idea that if when I multiply 87 times 7, you're really doing 7 times 7 first. So you're multiplying the 7 times the 7, you're getting your 49. And then how we choose to write it is we'll put a 9 here and we put our 4 here. And then we multiply 80 times 7 to get 560. We know that 0 times plus 9 is 0, so we just ignore that last term. And we go 56 plus 4 is 60. Right? And we added these two numbers together and carried our 1. So the concept comes into play that you're distributing, that you're doing 7 times 7 to get 49 and 80 times 7. Another way you can think about writing this is using the distributive property. You started off by saying 7 times 87. And then you can break out, well, your teachers taught you expanded form, where you broke it out and said 7 times 80 plus 7. Because 80 plus 7 is the same as 87. Another way I want you to think about this is it doesn't have to be this way. One of the things I want you guys to practice and think about developing is this idea of a number sense that says, okay, I don't necessarily have to do the exact same thing that's written here. How could I create a problem that's very similar to this? It equals the same numbers, just maybe not with the same exact digits. So another way to think of this is, what if I took and created a new equivalent expression that said 70 times 90 minus 3. So if you think in your terms, 80 plus 7 is 87. 90 minus 3 is also 87. So you can think about doing your math a little bit differently, that you could go, okay, 7 times 9 is 630. 7 times 3 is minus 21. 30 minus 21 is 609. The same answer we came up with prior doing the other method. So one of the things that a lot of students will start to realize is they've got classmates that can pick up and do these seemingly really large math problems in their head really quickly. What they'll typically have done is they'll figure this distributive property out a little bit. They'll have played with it based on kind of how their teacher taught them the standard algorithm, and they'll use this to very quickly do math problems. It's one of the most hidden skills when thinking about how to do these kind of problems is by just not necessarily doing the exact problem written, but doing something that means the same. And what the distributive property says, and you'll see it right here, is that if I multiply the sum of a number, I get one answer. If I multiply each add-in by the number outside the parentheses, I get the same answer. So that if I did 2, you did this, followed your order of operations and done 7 times plus 4 is 11. 2 times 11 is 22, is the same as 14 plus 8 is also 22. And it works the same when we have variables, that if A out here can multiply times B to plus C, even though I can't put B and C together because they're different letters, AB plus AC is the same. It's saying that I can either put them together and make them multiply by the whole, or multiply by the parts and put them back together. Either way, I'm still doing my steps. This really has a lot to build on as we work into algebra and how to break numbers apart and how to put them together in new and different ways. So one of the things that I mentioned earlier is that you've got these classmates that can really quickly think these through and seem to come up with ideas, seem to come up with answers really, really fast in class because they're thinking about numbers in a slightly different way. Here's one of the ways they might think of numbers. Now, normally, if we're going to do a problem like this, we talked about this beginning Unit 1, we would have multiplied 9 over 1 and turned this into an improper fraction and came up with 13 over 3. You would have cross-reduced down to 3 over 1 and came up with the idea of 39. That's not 39. There's 39. Okay? But using the distributive property, I can take one of my numbers, and we'll have to take the second one apart because it'll make it easier. Take this number apart into its parts and multiply it. So I can say 9, if I take this apart, times 4 plus 1/3. Now 4 plus 1/3 is the exact same as 4 1/3. It even has the word and in it, which signifies either decimal or even sometimes addition. So what the distributive property says, this is one way to do it. The other way might be to multiply each one individually and saying 9 times 4 plus 9 times 1/3. And this is one you could do in your head. 36 plus 3 is 39. And you might be able to do this in your head, but this is faster because I can take these numbers apart and work on them. Take a second and try this next one. See if you can take apart the fraction and create the mental math first, and then when you're done, illustrate the steps on how you came up with it. All right, so if you took it apart and you found your mental math, you came up with the idea of 42. Okay, so you broke it up and said, okay, 4 times 10 plus 1/2. And then you distributed. 4 times 10 is 40. 4 times 1/2 is 2. Together is 42. That's just one way to think of it. Now you can break it up more, you can break it up slightly differently. That's just the quickest and easiest way we can take a look at. But this is part of, instead of doing the problem that was written, we can do a problem that's easier that means that has the same value, that is equivalent. And that really is the key to building number sense and being able to manipulate the numbers and think of them differently, yet still get the right answer. And that's one of the great things about these properties. They allow us to look at things differently, yet still get the exact correct answer. So let's take a look at it with variables. So the distributive property is more likely to be used in a case like this. Because you can't put together what's in the parentheses. X and 3 are two different types of numbers. One is a letter, one's a number, one's a variable, an unknown number. The other is a number we can simplify. So since I can't put them together, the only thing I can do to make this problem simpler is to distribute. And I like to kind of draw these little partial rainbows to kind of think my way through. So one of the biggest things about this is I actually can't combine the 2 and the x. When I'm asking you guys what's an x, I'll ask you how many x's do you see, and you'll all tell me 1. So really what you have is this problem. Now, we don't write that one because of the identity property multiplication we talked about yesterday. Any number times 1 is itself. And we understand that if there's an x, then there's got to be one of them because that's how many we see, 1x. So what we're going to really do is combine 2 times 1 is 2x and 2 times 3. Now, understand, you can't solve this. There's no equal sign, there's no equation, there's no reason to solve it. It's just simply to put it together and to simplify it as best we can. Go ahead and try the next one as well. Try to simplify 5 times the sum of x plus 6. So once again, we have that 1 in front of the x, so it becomes 5x plus 30. Again, another way to think about it. I can't solve it any further. That's as simple as it gets. Now, let's take a look and explore it now with some mathematical terms, some word problems. So this time, what my goal is, you're going to find out how much y are needed, and you're going to write me 2 equivalent expressions before that. I've actually got 3 to come up with, so challenge yourself so you can see if you can find all 3 expressions that all mean the same thing. Okay? So if you work a problem like this, so we think about, okay, Fran is making pairs of earrings for bracelets. Because it's a distributed problem, I need to know what I'm multiplying all my other numbers by. So as I read, she's making bracelets for 4 individual friends. Each pair, so that's my key, I've got multiplication, each tells me this, that I'm multiplying, has 4.5 centimeters. And each bracelet, again, uses 13 centimeters. So one way I can do this is say, oh, okay, each friend's going to take 4.5 centimeters of wire to make the earrings. Each friend is going to make 13. So I can say 4 friends, 4.5 plus 13 is how I could figure out the answer. Another way is I can use my distributive property and distribute and say 4 times 4 and 5/10 plus 4 times 13. Okay? And finally, because it's both numbers, I actually could use my order of operations and go 4 times 17.5, or 17 and 5/10. Now there are an umpteen million more of these. I could break up my 13 into 3 and 10 and create it. I could break up my 4 and 5/10 into 4 and 1/2. There's so many other ways, but these are the most common ways that people come up with. And then and for me, I would probably use this method. 4 times 4.5 is 18. And 4 times 13, I know is 52. Okay, so I have a total of 70 centimeters of wire. Another way I can think of it, and this is just another thought process that I put on the video here, I could do 4 times 20 minus 2.5. That gives me 17.5. This is 80 minus 10 is that same 70 centimeters. So there's so many different ways to think about this kind of problem. Okay, so why don't you try this with Sue and her cookies and cupcakes. All right, so very similar. You had 5 batches. Each was another keyword here. 2 cups per batch, 3 cups per batch. So one way to write it would be 5 times 2 plus 3, or 5 times 2 plus 5 times 3, or you could break it up and go 5 times 5. These are all equivalent expressions. Each time you're going to find 25 cups of sugar. Okay. All right, now let's explore the opposite side of the distributive property. So if I can take a number, I can find everything they have in common, because that's what I'm doing by sharing what's in common, 5 times 2 and 3. 5 is the common number. I can multiply it. If I can multiply, I can also use it in the inverse. I can take numbers out. I can take out the common. And that's when you see the word factor, you're actually going to use the distributive property in reverse. Instead of multiplying each number, you're going to divide each number. So instead of multiply, you're going to divide. So if I think, what can I divide both 12 and 8 by? Well, there's several options. You could divide them both by 2. You can divide them both by 4. Either one would be considered correct. But I want to typically use the GCF, the greatest common factor. Okay? So if I would say, if I've got 12 plus 8, what's the greatest common factor? Well, it would be 4. So I could rewrite this problem as 4 times 3 plus 2. And that would give me the idea of it factored out. I took out the common. Okay? Why don't you try it on 18 plus 9? You're right. You found that you could divide them both by 9. So you have 9 times 2 plus 1. And those both work out the same way. It actually works the exact same way if I have variable terms. I look at, again, what do they have in common? Now for me, I typically look at the coefficient, and I'll talk about this vocabulary later, but the number in front of the x, because I can't go any bigger than that as my greatest common factor. So does 3 go into 15? Yes. So 3 divided by 3 is 1. So how am I going to write that? I'm going to write that as x plus 5. Go ahead and try that with 4x plus 20. You're right, you're going to divide them both by 4 to get 4 times x plus 5. Now I've got a couple bonus problems I want you to think about. I'm going to give you a little longer to think on these. Pause the video as you go. See if you can figure out how to factor these 2 problems. All right, now these were a little trickier. Finding the common number was pretty quick on this one. You knew they both divide by 7. But that's not the greatest common factor. What else do they have in common? Well, there's a minus sign in front of both of them. So what I really know is they're both negative. So if they're both negative, can I take, is negative also what they have in common? Yes. So what I really can factor is negative 7. Negative 35 divided by negative 7 is 5x. Negative 42 divided by negative 7, this time is positive 6. So you got to think, I factored the negative out. All I'm left with are my positive answers, because that negative times positive gives me back to my negative. Now this one's a little trickier because you can find the number 8. They both divide by 8. So that's the number I'm factoring out. But is there anything else they have in common? Your look right automatically would have been, oh, they have an x. Well, the first one has 2 x's. The second one has 1. So they have 1 in common. So I can factor an x out and make this 4x plus 5. Now these are a little higher up skills, a little later on, but this gives you a nice way to think about how can I work with using the distributive property to simplify expressions to work with. All right. You've got your homework tonight. Good luck. If you have any questions, please do reach out. I'm happy to help you all.